Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera to everyone. So we are still in lecture 1, soil composition, but this one will be the last part, which is part 3. Okay, now we are going to introduce simple equation for each of the components of volume and also weight to complete the phase diagram. For example, we divide each term or component with volume of solid equal to 1. Okay, everything will be considered based on volume of solid equal to 1. So what we are going to do now is, okay, based on the relationship between unit weight, void ratio, moisture content, and also specific gravity, we want to get, okay, the equations that relate to all of them, okay, that may relate to all of them, to all the index parameters of in geotechnical engineering. Okay, but now we are focusing on each of the elements. Okay, each of the element based on its volume. Okay, volume and also weight, or we consider as mass. Okay, but to achieve this, okay, there's a consideration that we have to make, which is we consider that volume of solid is equal to 1. Okay, so we consider volume of solid equal to 1. So what we did is we normalize all terms by dividing them by volume of solids. Okay, we normalize all of them by dividing them by volume of solid. As a result, we can develop some useful relationship between unit weight, void ratio, water content, and specific gravity. We start with normalize Vs with Vs, those make Vs equal to 1. Okay, we start with normalize the void ratio. Okay, we start with normalize the void ratio. Okay, because we know that this is the basic equation for void ratio, Vv over Vs. So we already consider that Vs is equal to 1. Therefore, void ratio will be equal to Vv. Okay, so we have void ratio, okay, equal to Vv. So the volume of void now is equal to E, right? So we know that total volume is equal to Vv plus Vs. So Vv is equal to E now, and Vs is already considered as 1. Therefore, total volume will be equal to 1 plus E. Okay, next we are trying to get the equation for other components. Okay, in this case we are trying to find the equations that relate to either unit weight, void ratio, moisture content, and also specific gravity for weight of solid. So how we make it this one? Okay, we knew that specific gravity is equal to Ws divided by Vs times with unit weight. Okay, by rearranging the equation, we simply can get weight of solid equal to specific gravity times unit weight of water. Why? Because we already consider that the volume of solid is equal to 1. Okay, so we have another equations for the components of solid, okay, based on weight. And now we work out on weight of water. Okay, we knew that water content is equal to weight of water divided by weight of solid. Okay, from previous derivation, we already know that weight of solid is equal to specific gravity times unit weight of water. Okay, thus it makes weight of water now equal to water contents times specific gravity times unit weight of water. So you simplify everything here. Okay, so you already know that the weight of solid, okay, from the previous equation is specific gravity times unit weight. Okay, and rearrange back the equations. Okay, so you got this equation. So we have another equations for the components of water with regards to weight. So in this case, we already have a complete set of equations for the components of weight based on weight of water and weight of solid. We don't have to find weight of air because it's always assumed equal to 0. Okay, now let's continue with another equations. Okay, and this times we focus on the volume parts. Okay, we focus on the volume part because we already complete for weight. Okay, so the same thing, we consider that volume of solid equal to 1. We already know what is the equation for volume of void, okay, from the previous derivations, okay, which is equal to void ratio, and we can simply calculate or sum up the total volume, which is equal to 1 plus E. Now we left with volume of air, okay, the components of air, okay, with regards to volumes, and also the components for water with regards to volume. So let's start with volume of water. So we use these basic equations of unit weight of water. Okay, we know that unit weight of water is equal to weight of water divided by volume of water. So from the previous slides, we already discussed on weight of water, right? So we know that weight of water is equal to water content times specific gravity times unit weight of water. Okay, and we simplified this solution, this equation by a simple mathematics. So make it volume of water equal to water content times specific gravity, because we can cancel out the unit weight of water. So now we have the equations for volume of water. Okay, so we almost get everything. We almost get the equations for all the components. We already have weight of water. We already find out for weight of solid. Okay, we already find out for volume of water. Volume of solid just now is the one that become the benchmark where we consider equal to 1. We already have volume of void. Okay, and we also have the total volume. We left volume of air. Okay, we left it with volume of air. So what I want you to do is, okay, try to solve this one. Okay, you can use, okay, the relationship between some index parameters, okay, that has the volume of air as the variables in that particular equations. Okay, now I want to show you the other equations that we can use. Okay, so now I'm going to discuss you, okay, further with additional equations that we can use for some parameters. Okay, for example, this one, okay, we know that this is the basic equations for degree of saturation. Okay, we know that degree of saturation based on its basic equation equal to volume of water divided by volume of void. Okay, so we know that volume of water is equal to water content times the specific gravity. Okay, water content with specific gravity from what we already discussed from the previous slides, and volume of void is equal to E. Okay, so you have these two. Okay, we use volume of water and also volume of void here. Okay, so we simplified it and it become these equations. Okay, and it can also be this equation, but this one, remember, okay, these two equations, okay, is applicable only if the conditions of soil is partially saturated. If the soil is partially saturated, because of why? Remember, if soil is partially saturated, it has all components of solid soil, which is air, water, and solid. So this is your void, components of void. So your void is consists of two things, okay, which is air and water. Okay, it's certain portions of water and certain portions of air. So we know that the degree of saturation will be ranged from more than 0, okay, and less than 1. right? So therefore you have the degree of saturation range of value. Okay, but if let's say the soil is dry, if the soil is dry, we know that SR is equal to 0. So this equation will no longer can be used. Okay. However, from this one also, if let's say we know that the soil is fully saturated, where we know that SR is equal to 1. So here it becomes void ratio equal to water content times specific gravity. So these equations is only applicable for soil where the conditions of that particular soil is fully saturated. Only when the soil is fully saturated. If it's partially saturated, you have to use these equations. Okay, and if it's dry, we cannot use that both equation. Okay, there's no way to use these equations or even these equations for dry soil. So remember, okay, another equation that we can use instead of for void ratio, we know that the basic is VV over VS. Okay, but you can also use these equations. Okay, this equation for void ratio, to calculate void ratio if the soil is fully saturated only. And you can also use, okay, these equations, okay, we simplify it, E equal to WGS over SR, okay. Another equations for void ratio, instead of using these equations, okay, instead of using these equations, you can also use this equation for soil in partially saturated, okay. But if the soil is dry, you cannot use, okay, either this equation or even this equation. Remember that. Okay, next, okay, let's discuss on the other equations that we can use for other parameters, okay, of index parameters. So in this case, okay, we discuss on air void content equations. So this is the basic equations for air void content. It is equal to volume of air divided by V, and we know that okay, this is your volume of air, right? Okay, so volume of air is equal to volume of void minus volume of water. Okay, so it's equal to volume of void minus of volume of water, okay, divided by total volume. So we know that total volume is equal to 1 plus E. Okay, so we know that VV, okay, from this diagram is equal to E, and VW is equal to WGS, right? And we can also simplify it more, okay? Okay, from the previous slide, we know that WGS for partially saturated, okay, it is also equal to SRE, okay? This WGS equal to SRE is only for partially saturated soil. Partially saturated soil. So we simplify, okay, those equations, okay, become here and become also this one. And we know that if you focus on this part, E, okay, divide by 1 plus E, okay, is equal to N. Okay, just look back, okay, our discussions on this lecture 1, soil composition, if I'm not mistaken, is in part 1. Okay, is in part 1. We know that there's a relationship between void ratio and porosity, where porosity can also be calculated as E divided by 1 plus E. So we simplified this one and it become this. Again, be careful. This equation is only applicable if the soil is in partially saturated. Okay, in partially saturated. If the soil is dry, okay, we know dry SR is equal to 0. Still can also be used this equation, okay, okay. But if the soil is fully saturated, this is not function. Okay, this equation cannot be used for fully saturated. Why? Okay, because you minus with, for fully saturated, SR is equal to 1. So 1, you minus 1, you become 0 here. So you cannot use the equation. So these equations can only be used, okay? These equations, okay, can only be used for partially and also dry. Okay, because when talking about partial, it has a range from the SR is range from more than 0, less than 1, and if it's dry, so SR is equal to 0. Okay, so AV will equal to porosity. Okay, in addition to that, okay, we can also have more derivations, okay, for other parameters. Okay, for this slide we discuss on gamma saturated. Okay, we know that whatever unit weight, okay, it is definitely equal to total weight divided by total volume. It's just that what are the components of weight and what are the components of volume that exist on that particular condition will be considered. Okay, so when talking about gamma saturated, we know that we are referring to fully saturated. Okay, we are referring to fully saturated. So if the fully saturated, you only have water and solid. Okay, you only have water and solid. So if you're talking about weight of total weight, so you have weight of water plus weight of solid. Okay, this one. Okay, and if you're talking about total volume, so definitely you have volume of water plus volume of solid. Okay, and we know that total volume is equal to 1 plus E. Okay, so we already know that weight of water is equal to this equation. Okay, and weight of solid is equal to this equation. So we simplify it based on very simple mathematics solution. We'll have this equation. Okay, we will have these equations, and we know that for fully saturated, E is equal to, can also use this equation. Okay, E is equal to WGS. So you can also use that equation. Okay, and okay, we know that if you convert this one, let's say GS plus WGS, okay, over 1 plus E gamma W, this WGS for partially saturated is equal to SRE. So you can also have another equations for bulk unit weight by using this equation. Okay, and how about for dry? Okay, if you look at this one, okay, I'll delete everything first. If you look at this one, okay, SRE, okay, if dry, SR, okay, for dry, SR is equal to 0, right? Okay, so therefore, for dry, if you want to convert the equations to dry, so it's only equal to GS, because SR is 0, so it will be 0 here, 1 plus E times unit weight water. Okay, so now we have another equations, okay, for those three conditions of soil. Okay, for partially saturated, you can use this equation, SRE 1 plus E unit weight of water. Okay, for fully saturated, which is gamma sat, okay, because we know that SR is equal to 1. Okay, so it will be left with GS plus E 1 plus E unit weight of water, or because we know that E also equal to WGS for fully saturated, so you can also have this equation, GS plus WGS 1 plus E unit weight of water. Okay, and simplify this one, you will be GS 1 plus W, right? 1 plus E gamma W. And for dry, okay, talking about dry, okay, I'll delete this one first. Okay, for dry, Okay, for dry, okay, because we know that for dry, SR is equal to 0, so you will have GS over 1 plus E unit weight of water. So we have complete everything. Okay, another one is for gamma set, just rewrite back, equal to E 1 plus E unit weight of water. Okay, next, the same thing also like a previous discussion, but this times we look at the relationship between weight, porosity, moisture content, and also specific gravity when we consider that total volume is equal to 1. Previous discussion, we consider that Vs is equal to 1, right? But now we change it to total volume equal to 1. So the same thing also, try to fill up all these components, okay, weight of water, weight of solid, volume of water, and also volume of air, each of them, by using the relationship from the index parameters. So you can use whatever index parameters, for example, that unit weight, porosity, moisture content, and specific gravity, to simplify that. Okay, so find the easier way first. Okay, we know that in this case, okay, we know that the basic equations for porosity is VV over V. So now we already consider that total V is equal to 1. Therefore, VV is equal to M. Okay, and we know that VS is equal to get VS is equal to total volume minus VV. So we know that total volume is 1 and VV is equal to 1. So it becomes VS 1 minus porosity. Okay. Okay, now let's work out on weight of solid. Okay, by using the relationship between specific gravity and also unit weight of water. Okay, so you know that specific gravity, the basic equation is this one. So we already have the equations for volume of solid. Okay, we already found the equation for volume of solid. So forgot to put gamma W here. Okay, so we arrange back the variables. We have these equations for weight of solid. And now find out for weight of water. Okay, by using the relationship between water content. Okay, water content is equal to weight of water divided by weight of solid. Okay, this is the basic equation. Okay, this is basic equation for water content. So we already find the weight of solid just now. Okay, so simplify everything. Now we got this equation for weight of water. Next, finding the equations for volume of water. Okay, by using the relationship of unit weight of water. So we know that this is the basic equations for unit weight of water. We already derived the equations for weight of water from the previous slides. Okay, therefore rearrange back this volume of water become the main variables. So you have these equations. Okay, that's all for this topic. The first topic, which is under soil compositions, we already discussed everything. I already discussed with you all the basic equations in geotechnical parameters. Okay, basic equations for index parameters, which is void ratio, porosity, degree of saturation, and void content. Where all the basic equations is based on volume, and you also have water content, which based on weight, and you also have unit weight, also known as density, and specific gravity achieved from the relationship between volume and weight. Okay, and we also discuss on the equation of each components, okay, by using the relationship of index parameters, okay, unit weight, water contents, and everything, okay, by certain considerations where initially we consider Vs is equal to 1, and then we consider total volume is equal to 1. So we have another derivation. So that is actually some of the example how we can derive the equations. Okay, and those derivation has their own limitations. Okay, for example, that there are some equations is only applicable for fully saturated, some equations only applicable for partially saturated. Okay, where maybe dry type of soil is not applicable to use certain equation, and it not only limited to that. Okay, you may able to derive your own equations. Okay, your own equations. All right, so it's not only limited to what we already discussed just now, so it can be further explored. Okay, but the one that we already discussed is some of the example. So I hope that everyone can understand this topic very well. Okay, I'll see you later in a tutorial video. With that, thank you very much.